Hi there and welcome to CodeFramer.
So this video is the part 2 of the Docker training session where we will be doing the hands-on with Docker. So as a prerequisite, you will need an AWS account for this training session, and creating an AWS account is a very simple process. You can refer many different videos in YouTube and you can create your own account. So I have an AWS account for myself. So if you don't have it already, then you can just pause the video here and you can go and create an AWS account for yourself and then come back to the training. So before going to the AWS account, we will just look at some of the commands using which we can see all the CGroup distribution of all the containers and also the main Docker daemon server. So as you can see in the slide that these are the commands using which we can see the distribution of the CPU and the memory resources across different C groups. So I already have an EC2 instance running in the AWS account with CentOS operating system. So let me copy this command and execute the same in that Linux server. So if you see in this output, it basically gives us the view of the control group hierarchy. And since we have mentioned CPU in our command, it specifically gives us the hierarchy of control group for the CPU resource. Similarly, we can also see the control group hierarchy for the memory resource. So the Docker is already up and running in this particular server. So first let us try to find the C group where Docker process is running. So as you can see in this output that Docker C group is running under the CPU where we have two containers processes running, and under the processes we have all the sub processes running. So this is how we can find and locate Docker C group within the CPU resource, and also we can see what are the different processes that are running inside the containers. So as I mentioned earlier, that the same way we can also have a look at the C groups which are under the memory resource. So let me now execute the same command with the memory resource. So as you can see here that there is a C group for Docker which is running and which has certain containers which are running as a process within the C group, and the process IDs are, for example, 2811 which is running inside a container, and then we have 27376528. These are some other processes which is running inside another container. So this is how you can locate different containers and also the processes that are running within the containers in the memory C groups. So in the C group output, we were able to see two containers. So now if we come out and we execute the docker ps command, you can see that we have two containers running. So using docker ps command, we can just list out all the various containers that are currently running in the Docker engine, just like how we have the ps-ef command where we can see all the processes running in a Linux system. Similarly, in the Docker, we have docker space ps, using which we can just list out the processes which are running in the Docker engine. So as you can see in this output that we have two containers running, and the first container starts with the name 103bb. Now if you go to the C group output, you can see that the name of the container is given here, which starts with 103bb, and you can see that there is one process which is running inside the container. So basically in this way we can just check what are the different C groups, what are the different processes running within the C group, how many different containers are running, and the processes which are running inside the containers. Now let us see the various namespaces using which different processes are running in the Linux system. So in order to check the namespace of a particular process, let us first execute the ps command. So as you can see, there are some processes which are running at the root level in the CentOS operating system. So for example, if we want to check the namespace of the process 2811, then we can give the command ls-l space proc process ID, and then we can say ns. So here ns is nothing but the namespace. So as you can see here that there are 6 different namespaces using which the process ID 2811 isolates itself from other processes. So all these namespaces are explained in the part 1 video, where the first namespace is the inter-process communication namespace, second is the mount namespace, network namespace, then we have the process ID namespace, then the user namespace, and finally the Unix time sharing namespace. So using these namespaces, we can create the required isolation for all the processes which are running in the Linux system. So as I mentioned in the previous video, that namespace is a functionality which is already available in the Linux operating system's kernel. And as you can see that we were already using this particular functionality in order to create necessary isolations for all the processes that are running in the Linux system. Similarly, when it comes to Docker and containers, and since containers are also treated as a process in the Linux system, we can use the same namespace functionality which is provided by the Linux kernel in order to create the necessary isolation for each container. So now, having understood about how to check the C group and also how to check the namespaces of any process, let us go to the AWS account and create an Ubuntu server, and then we will install Docker inside the Ubuntu server. So first open Google and then give Amazon EC2. Then you will find the link, then click the first link Amazon EC2, and then it will take you to the Amazon page, and then give create a free account. And here you can give the sign in option because you would have already created the account by now, so you can simply give the sign in option, which is at the bottom. And here you can give your username as the root user, and then provide your password and then sign in. So this is the home page. Here you can go to the services option, which is at the top, and then you can click on EC2. And now you can click on the instances menu on the left. So once this window opens, we can start creating Ubuntu server or any kind of server like CentOS server or any other Linux operating system distribution. We can create those servers and then we can log into those servers. So in order to create an Ubuntu server, click on the launch instance button, and then in the search section you can give the name of the operating system, which is Ubuntu. And similarly, if you are looking for a CentOS operating system, then you can simply type CentOS here. But since we are looking for an Ubuntu operating system, and then you can select Ubuntu Server 18.04. And notice that this is a free tier eligible, which means that if you keep the server open for any amount of time, you won't be charged. But for example, if you want to create an CentOS server, then it can be charged from your AWS account. So money can be charged from your AWS account. So it is always better to go for an Ubuntu server and also look for the free tier in AWS so that you are not charged for the usage. And also, as you can see, that we have some other details given here, like we will be allocated one CPU core and also 1 GB of memory if we go for the free tier. So for the training purpose, we can go with the free tier, but for commercial usage, you can go for higher plans where more resources will be provided. So after selecting the instance type, then you can move forward by clicking next to configure the instance. So in this window, we can do the configuration of our instance. So for example, if we want more than one instance, then we can give multiple instances in the number of instance field. For our purpose, since we are going to use this instance only for training purpose, we will just press next and go to the storage configuration. So in this window, we can configure our storage space that we require for our server instance. So as you can see that we have the root volume where we have configured 8 GB of space, and also if you want any additional volumes, you can just press the add new volume button and you can configure more volumes. So we can configure up to 30 GB for free tier, but if we go beyond 30 GB, then it will be chargeable. But as far as free tier is concerned, we can configure the volumes up to 30 GB for a particular instance. So for our purpose, we don't have to make any modifications here, so we will simply click next and go to the tags configuration. So we don't have anything to configure in the tag section because we are creating this EC2 instance for training purpose. So let us move forward. So in this tab, we can configure the security group, which is nothing but a virtual firewall for our EC2 instance. So you can either create a new security group or go for the existing security group. So we will go for the existing one, where we can simply select the default security group, which simply allows all the traffic towards our EC2 instance. So now let us click review and launch, where we can just review our instance, all the configurations that we have done for the EC2 instance. We can just review it once and then we can press launch in order to launch the EC2 instance. So after pressing launch, we can select a certificate. So either you can create a new certificate or choose an existing one. Since we have an existing certificate, then we will go with it. And then finally, you can view the newly created instance. So as you can see that the instance is getting created and it is coming up. So we can give a name to this particular instance. Currently the instance status is pending. So once it is up and ready, then the status will change to running. So for this training session, we will just name the instance as Docker Ubuntu. So as you can see that the EC2 instance status is still initializing. So now it is complete. So once the instance is initialized, a public IP will be allocated for this particular EC2 instance, using which we can access this particular server. So as you can see that we have an IPv4 public IP. So we can copy this particular IP and then we can open MobaXTerm. So if you are not familiar with MobaXTerm, it is also just one of the softwares like Putty or Secure CRT, using which we can access servers. Only thing is it is more user friendly, and also we have a tree view using which we can view all our servers that we have configured, and also we can easily access them. So as part of this training, you can also download MobaXTerm from internet. You can just Google the name and you can find the setup file and download in your system. So once you have opened MobaXTerm, then you can click on sessions, click on SSH, and then in the remote host, you can give the public IP of your EC2 instance. Then you can provide username as Ubuntu because that is the default username for an Ubuntu EC2 instance. And then finally click on advanced SSH settings where we will click the checkbox use private key. This is where we can select the private key that we have configured during our EC2 instance configuration. So if you remember at the end of creation of this EC2 instance in AWS, we selected a particular private key. So we can use the same here. And if you're thinking that how we can download that particular certificate from the AWS account, then when you will be creating the certificate the first time, so at that time when you create the certificate, automatically it will get downloaded into your local system. Since we used an earlier existing certificate, that is why the file was not downloaded, and it was already downloaded in the system, so that is why it did not get downloaded. But if you are using it for the first time and you are creating the certificate for the first time, then automatically it will get downloaded. So after it is downloaded, you can just locate the path of the certificate in the private key and you can pull the certificate in the MobaXTerm. So as you can see that once we have completed all the configuration of the EC2 instance in the MobaXTerm, automatically the server is accessed and it is logged in with the username Ubuntu. From here, we can install Docker into the server, and then we can start creating containers and we can start performing various operations using containers. So let us start exploring. So first let me switch to the root user with sudo su. So as you can see, now we are in the root user. So first let us change the host name of the server to docker2 for training purpose. So we'll say hostname docker2, and also let us change the name in the etc hostname file. So after updating the host name of the Linux system, the first thing we can do is to update the software package of the Linux system by the command apt update. So as you can see that the installation of all the software packages is over. So now we can go ahead and install Docker. So in order to install Docker, we can execute the command apt install docker.io-y. So this is a very simple command which you can use to install Docker into the server. So as you can see that Docker is getting installed. So allow the installation to complete. So as you can see that the Docker installation is complete. Now in order to validate this installation, we can give the command docker space version. So if you are also getting this output after giving the command docker version, then it means that Docker is successfully installed in your operating system. So as you can see that we are getting the version of both client and the server. So if you remember in the last video, we understood that Docker works in the principle of server client architecture, where server is nothing but the Docker daemon and the client is nothing but our CLI. So the CLI will send all the commands towards the Docker daemon or the server, and the server will process that command, perform the operation on the containers, and then it will respond back to the client. So if you are getting this output after executing the command docker version, then it means that Docker is successfully installed, and going forward we can use the docker command in order to create containers. And also if you notice here that we have some information given in this output, like for example, the version of the client, which is 19.03.6. Then we have the API version, which is nothing but the REST API, which is between the client and the server. So the version of that API is 1.40. And then we have the Go version. Go version is nothing but the programming language using which the Docker has been written, which is the Go language. And the version of the language which is used is 1.12.17. So these are some of the basic information which is given for the client side of the Docker. And then in the server, as you can see, we have similar information like the version of the server, which is 19.03.6, and then we have the API and the Go version. So these are some of the basic information about the client and the server of the Docker. So if you remember from the previous video that the Docker engine consists of the client and also the server, and since these two are installed in the Ubuntu server, it means that Docker engine is basically up and running. So now we can perform various operations by creating containers and managing containers using this Docker engine. And one quick point, we can check the Docker version using two commands basically. One is the docker -- version, which will just show the version of the Docker like this, and another one is the docker space version, which will show the version of both client and server. Before continuing any further, I also want you to get introduced to one of the open source lab which is available for Docker. Basically there you can create your own account and then you can simply log into that lab and you can create an instance of Ubuntu server and then you can practice any command in the Docker. So in order to access that lab, all you have to do is open the Google Chrome or any of your favorite browser and then just give labs play with Docker and go into the first link. So as I'm already logged in, so I am getting the start button. But if you are not logged in, or if you don't have any account in this particular web application, then you can simply do a sign up. And once you have created your credentials, then you can simply log into the web application and then press the start button. So as you can see that this particular lab is available for us for the next 4 hours. So which means that it has a drawback that if you create multiple instances of servers, and then if you create multiple containers and do your own configuration in order for the purpose of learning and training, then that configuration and those containers will be lost after 4 hours. So after 4 hours is completed, you have to again create new instance and all your older configuration will be lost. So that is one drawback, but I think for training and learning purpose, this is the best option. So if you don't want the hard work of creating an account in AWS and creating servers there, then definitely this is one of the options that you can use directly. So it's simply a link which you can just Google and find, and then you can create your credential, and then after login you can create your server instances and start practicing Docker. So in order to create a new server instance, all we have to do is click on the add new instance button. So as you can see that we now have a new server instance, and also an IP address is allocated for this particular server, 192.168.0.28. So now this server is already installed with the Docker engine. So Docker engine is basically up and running. So if I execute the command docker space version, then as you can see that we are getting the version of both client and also the server. So basically the Docker engine is up and running, and now you can create your containers, you can manage containers and perform all operations. So basically you can use this server for training and learning purposes. But yes, I want you to remember the drawback as well, that after the time is completed, which means the 4 hours is over, then basically all the configuration of this particular server instance will be lost and you have to create a new instance and practice again. But I still highly recommend you to go for the AWS account and create your server there, because there you can create multiple free tier servers, and then you also have a feasibility that all your configuration or practice containers will be stored and they won't be lost. So you can simply pause those servers and then you can later log into those servers again and start practicing from where you left. So that is one of the better options. But yes, if you don't want an AWS account, and also if you don't want to create your servers in the AWS, then definitely you can use this option. And also as part of this training, I'll be using this lab in order to explain certain concepts. So having introduced you to this open source lab, so it's absolutely up to you. You can either use AWS account or you can directly practice in this open source lab. So now let us go back to the AWS setup that we have created, and from there we will start our practice. So lastly, we saw how we can check the version of the Docker engine. So now if you want to check more information about the Docker engine, then you can give Docker info. So as you can see that in this output, we have a lot of information. So one of the information that is very useful here is that the number of containers that are running, and basically you can also check the different states in which these containers are running. You can also see the number of images that we have. And also as you can see that there are various states given here, like running, paused and stopped. So basically this command docker info gives us the overall information about the life cycle of all the containers that are running. And then we have the storage driver, which is the overlay too. So basically you have a lot of information here. And also as you can see that there are certain plugins given here, like volume, network and log. So in the network, you can see that we have networks like bridge network, host network, MAC VLAN network and overlay network, which basically means that the Docker engine has the required plugins to support these network configurations. So now the question is, from where this Docker info is basically coming. So if you execute the command ls var lib docker, then you will find all the configuration files of the Docker engine. So it is from this particular folder, all the information about the Docker engine is basically fetched in the docker info command. So as you can see that we have containers, images, network, then we have volumes, all the plugins, swarm. So all these configurations are stored in this particular folder. So just remember that all the information about the Docker engine can be found in this particular folder and in these files. So here I am just showing a snippet of the files that you can expect inside these folders. So as you can see, when we get into the containers folder, we don't have anything because till now we have not created any containers. And then when we go inside the image folder, we have the overlay 2. And then when we go inside the overlay 2, we have certain other folders like ImageDB and LayerDB. Then we have repositories.json. Basically, all these files are related to the Docker engine, and we won't be using these files much, but just for information purpose, you can know that all the configurations or all the files related to the Docker engine will be available in this particular folder. And the more containers or networks or Docker Swarm or volumes you will create, all those configurations will be stored in these folders only. So now, having understood the basic commands related to Docker engine like Docker version and Docker info, which is basically to ensure that the Docker engine is up and running in the server, now let us move on to some other concepts that we understood in the previous video, that is related to the Docker public repository. So we have different open source images that are available in the Docker public repository, which we can pull into our local host machine, and then using those images we can create containers. So now let us slowly move towards making containers using various images. So in order to make containers using the images, we have to first pull the image. So we can pull the image from the public repository, which is the Docker Hub. So first let us see what are the images we already have by giving the command docker images. So as you can see that we don't have any image right now in our host machine. So in order to pull the image for Ubuntu, we can give the command docker pull Ubuntu. So this will basically fetch the image from the Docker Hub, which is the public repository. So as you can see, it is getting pulled. So now the image has been installed. So now if we give the same command docker images, then as you can see in the result, now we are able to see the Ubuntu image. So in this output, we have certain parameters, right? For example, the tag, the image ID, created, and size. So basically the tag, it is showing as latest, right? Which means that the image which is downloaded in the host machine, it is of the latest version. So similarly, you can download any particular version of the Ubuntu image. But if you do not give any version in your command, then the most latest version will be downloaded. So that's what the tag means. So it says latest, it means the most latest version of the Ubuntu image has been downloaded. Now the next parameter is the image ID. So as you can see, we have a random ID generated which we can use to identify this particular image. So it's a unique ID. And then we have the created date, which says as 12 days ago, which means that this particular image of the latest version was created 12 days ago. Now the last parameter in this output is the size. Now this is where I want to bring your attention into. So as you can see that the size is 74 MB, which means that the entire Ubuntu operating system is basically of 74 MB, which is very strange, right? Because usually operating systems are very heavy. For example, a CentOS operating system will be in GBs, and similarly even an Ubuntu operating system will be in GBs, right? But here as you can see that the very Ubuntu image is just of 74 MB, which is very small size. Now how is that possible? If you remember in the last video, we understood that how Docker engine basically uses its underlying host machine's operating system's kernel, right? So all the kernel functionality of the operating system is being used from the host machine's operating system, but the top level functionality of the operating system of the Ubuntu is used from the image. And that is the reason why the Ubuntu image is so lightweight. It is simply because the top level functionality of the operating system is in the image, but the kernel functionality of the operating system will be borrowed from the underlying host machine's operating system. And this makes the containers extremely lightweight. So now if we use this particular image to create containers, then you could imagine that the entire operating system size of that container will be just 74 MB. And on top of that, we can install our application and store our application data. So having understood about the image size and its parameters, let us move forward. So using the command docker pull image name, we can pull any image from the main Docker Hub, right? But it doesn't mean that if you give any name in the docker pull command, it will simply pull it. So for example, if we give the command docker pull ABC, then as you can see that we are getting an error that the access is denied for ABC because there is no such image which is there in the main Docker Hub, which is of the name ABC. So as you can see in the error that it simply gives a message that repository does not exist or may require Docker login, which basically means that there is no such image in the Docker Hub which is called ABC. So also now if you see the Docker images, then as you can see that the ABC image is not downloaded. So now let us move forward and try to download some of the other images that are available. For example, MySQL. So you can download the MySQL image by using the command docker pull MySQL. So as you can see that the image is getting downloaded. So now if we give the command docker images, then as you can see that now we have two images, one is Ubuntu and another one is MySQL, which we just downloaded, and the size of this particular image is 541 MB. So having understood how to pull an image, we also need to understand how to remove an image. So we can remove any particular image using the command docker rmi, and then we can give the name of the image, for example Ubuntu. So as you can see that the image has been deleted. Now if you notice in this output there are some random text which is given as deleted. Now what are these text? These are nothing but the instructions which were given in the image. So the Docker engine basically writes all the instruction in the image as an encoded instruction in the SHA-255 format. So it uses basically the SHA-255 encryption in order to write all the instructions inside the image. So if you want to see where these image instructions are written, then you can go to the path ls where lib docker and then overlay to. So as you can see, there are some instructions written here in the SHA format. So these are basically the instructions which the Docker engine uses in order to create containers from the image. And also as you can see that it keeps all the instructions in encrypted format so that it is not readable by the user. So now let us try to pull the Ubuntu image back so that we see if any changes are made into this particular image instruction file. So as you can see that the image is getting pulled. So let it download. So now if you see, the number of lines in this output has increased a little, which means that the instructions which were available in the Ubuntu image are now added into this particular file. So just remember that it is not something that it is required for your operational knowledge in order to work with Docker, but yes, it is always good to know these things. So as you can see that these information are something which is used by the Docker engine to create containers. So basically these information are not related to the actual application data, but these are related more to the Docker engine itself for it to create containers. So now the question is, where are these information basically stored? So if you remember, in the docker info command, we saw one parameter which is called storage driver, and the storage driver is overlay to. So let me explain a little more about the storage drivers. So ideally, if you think about it, a very little amount of data is written in containers writable layer, because container itself will need certain amount of data for it to function, and that is a very little amount of data, and we use the docker volumes to write such data. However, some workloads require you to be able to write the containers writable layer. So this is where the storage drivers comes in. Now the Docker supports several different storage drivers using a pluggable architecture. So basically Docker has a pluggable architecture where you can use different kind of storage drivers as per your requirement. And the storage drivers basically controls how images and containers are stored and managed in the Docker host. So as you can see that since we have storage driver as overlay to, the instructions of all the images that are pulled are stored in the path where lib docker overlay to. So if you add any image, then all those instructions will be added in this path, and if you remove any image, then all the instructions will be removed. So now let us move forward and see how we can create containers using these images. So before creating the containers, let us first list out the images that we have pulled. So we have basically two commands. One is the old command using which we can see the list of images, which is docker images, and now with the latest version of Docker, the command has changed. Basically the commands are kind of more modularized now. So based on the component of the Docker on which you are performing any task, the command has been organized in the same way. For example, if we give the command docker space images, then it will list out the images which are downloaded in the Docker host. So as you can see, there are two images. So this was the old command. Now the new command is docker image ls. So as you can see that after docker, we are writing image in the second command. And after writing the image, we are basically passing the instruction which we want to perform. For example, in this case, we want to list out all the images. So we are saying docker image ls. Similarly, if we want to perform any other operation in the image component of the Docker, then we can simply write that instruction after the docker image command. So this is the new format of the command where you can write docker space and then you can write the name of the component on which you want to perform certain action. For example, in this case, since we want to perform an action on the image, so we can write docker space image space ls. Similarly, if we want to perform any operation in the network, then we can write docker space network and then we can pass the instruction. Similarly, if we want to do any operations in volumes, then we can write docker space volume and then we can write the instruction. So this is how the new commands in Docker are organized. So if you want to perform any action on a particular component of the Docker, then you can simply mention docker space and then the name of the component and then you can pass the instruction. So now we have finally reached a point where we can start creating containers. So now let us see what is the command we can use to create the container. So the command is docker run, and then we can write -it, which stands for interactive terminal. Now basically -it creates an interactive bash shell in the container, which means that when we are inside the container and we give the command exit, so automatically we are able to come out of the container. And this is happening because of this -it, because when we give the command exit, it basically passes the exit code command to the docker run, which we executed to get into the container. So hence this -it ensures that all our interaction is basically in the interactive mode with the the container. The next argument is -d, which is nothing but running the container in the detached mode. So D stands for detached. It means that we will run this container in the background as a background process. So there are many different processes which is running in the Linux system, right, in the background. So we will run this particular container in the background process, which means that once you are inside the container and later if you come out of the container, then it will have no impact on the container because it is running as a background process. And this is simply happening because we started the container with the detached mode, which is by giving -d in the docker run command. And finally, we can give the name of the image using which we want to create the container. So in this case, it is Ubuntu. So as you can see that a unique container ID is generated here. So in a normal system, since we will have n number of containers, so these unique identities are very important to access a particular container. So Docker engine ensures that a unique ID is created for each and every container that we create. So we can see the list of containers using the command docker-ps, because as I mentioned earlier in the previous video also, that each and every container runs as a process in the Linux system. So if you give the command docker-ps, then you can see in the result that the container is up and running. So in this output, we have few parameters which are basically self-explanatory. So for example, if you see, we have container ID, which basically shows a unique ID which is created for this particular container. So this unique ID we can use to identify this particular container. And then we have the image which shows us using which image this particular container is created. So it is using the Ubuntu image. And then we have the created time. So this particular container was just created 29 seconds ago. And then we have the status which shows us up, which means that 28 seconds before this particular container got up. And finally, we have the name of the container. So basically, since we did not give any name by ourselves, so Docker engine has given its own name, like pensivm. It's just a random name which it has given to identify this particular container. So Docker engine basically gives a unique name also to the container for you to identify. And it is a more user-friendly name, because as you can see that the container ID is not user-friendly. It is a very random code. So it basically gives a user-friendly name like a pensivm. So you can use this name to access this particular container. So now let us get into the container. So we can use the command docker exec -it, and then we can pass the container ID, which is the unique ID using which we can identify the container. And finally, we can write bash. So this is the command using which we can get into the container. So now as you can see, we are inside the container now. So the reason why I'm saying that we are inside the container is simply because earlier we had root at docker2, which is the name of our Docker host, but now it is root at the container ID. So now we are inside containers environment. So now this container will have its own namespace and file system. So if you give ls, then as you can see that we have all the folders and files. Now any modification in these files will have no impact on the host machine or its file system. And if you want to come out of the container, then simply you can give the command exit. So as you can see that we are back to our Docker host machine. So now let us see what happens when we do not start a container in detached mode. Because as I mentioned earlier that when the container is running in detached mode, then even if you come out of the container, it will still continue to run, right? But if you do not run a container in the detached mode, then let's see what really happens. So if I say docker run -it, and then if I directly write the name of the image, which is Ubuntu, so currently the container which got created, it is not running in the detached mode. So which means that it is running in the foreground mode. So now let us come out of the container by giving the exit command. So now we are out of that container. And now if you see docker ps, then you will notice that the container that we created just now is not available in the docker ps command, right? Which basically means that the container is not running anymore. But if you give the command docker ps -a, then it will show all the available containers. And as you can see that the container which we just created, it shows the status as exit with 0 code. Now 0 code is normal exit, which means that we manually came out of the container without any issues or errors. And that is why it shows as 0 error code. So it simply means that whenever we do not create a container or run a container in the detached mode, and then if you are coming out of that particular container, then automatically that container will come down. It will be in the exit state. So which basically means that that particular container will not run in the background as a background process. So if you want to run any particular container as a background process, then always remember to give the -d in your docker run command, which is to make the container run in the detached mode. Now say for example, if you want to convert a docker container running in the detached mode to the attached mode, then that is also possible. So what you need to do is give the command docker attach and then pass the container ID. So this will automatically move the particular container from the detached mode to the attached mode, which means that again, if you come out of this particular container, then this will also go to the exit state. So basically it will stop running as a background process. So now if we give the command docker ps, then as you can see that none of the containers are running right now because both the containers are running in the attached mode. But now if we see docker ps-a, then as you can see that we have exited state in both the containers, and both are exit with zero code, which means that it is a normal exit without any errors. So this is the difference between the detach and the attach mode. So now if you want to bring these containers up and running again, then you can use the docker start command. So you can give docker start and then you can pass the container ID. So if you press enter, then automatically this particular container will come up, and similarly you can bring up the second container as well. So now if we give the docker ps command, then as you can see that both the containers are now up and running. So using the docker start command, you can bring any container up again. So here I am concluding this video in order to keep the video length in control. So in this particular training module, we saw how we can check the CGroup and namespaces of containers. Then we saw how to create an EC2 instance in the AWS account. And then we looked at how we can log in into the server using the MobaXTerm. And you can basically use any other tool that you have, like for example Putty. And then we saw how we can install Docker into an Ubuntu operating system, and how we can validate whether the installation was successful or not by using the docker version command. And also we had a look on the docker info command, and also we looked at from where the docker info basically fetch all the configuration related to the docker engine. And then we looked at the test lab, the open source test lab, which is play with docker. So if you don't want to use the AWS account, then simply you can log into the play with docker test lab and you can start practicing. It is more than useful for practice and training purpose. And then we saw how we can pull images from the Docker Hub, and we also saw how we can manage those images, like we export some remove commands. We saw the command docker images ls, and we saw the rmi command using which we can remove any particular image. And then we also saw how we can create containers and also manage containers. And finally, we looked at how we can get into the Docker container. So I hope that this particular session was useful and you were able to grasp all the concepts. In the next video, we will further explore Docker and we will see a lot of other concepts as well.
If you like this video, then hit that like button, share it with other code lovers, and also subscribe to CodeFramer for more videos. Thank you and see you next time.